Hello.
Hello, Jane.
Hello.
You lost your connection, is it?
Yeah.
Okay, no problem. We'll just carry on, okay? Yeah, so I was talking about this question 11. Could you hear me, Jane?
Yeah.
Okay, I was talking about this question 11, and I'm supposed to find the weight of the box. So given that the mass is 20 kg, how do you convert this mass to the weight?
Newton, I think.
200 Newton. You're right. You just have to change the mass in kg to weight in Newton by multiplying with 10. Right? So you will have the weight equals to 20 kg times 10, which gets you to 200 Newton. Okay, so what is the size of the frictional force acting on the box, and explain how you can obtain your answer. So what is the size of the frictional force? Now, if you read the question carefully, it says that the box is moving on a horizontal force at a constant speed of 0.2 meter per second. Now, do you remember what is the meaning of constant speed? Constant speed is always referred to as zero acceleration, right? Okay, so this one has a zero acceleration. Okay, so if there's a zero acceleration and we use the F equals to ma formula, can you see that this means that acceleration equals to zero, which also means that the resultant force is also equals to zero, right? Because if you sub A equals to zero, F will definitely become zero, right?
Yeah.
Hello. Okay, so resultant force is zero. What do you mean by resultant force is zero? Remember, we talked about balance forces. If the forward force and the frictional force are equal, they cancel out each other, then there'll be zero resultant force. Got it?
Yeah.
Okay, so let me scroll up. All right, so with a zero resultant force, then it means that there are balance forces. This also means that the pushing force or the forward force is equal to the frictional force. Is equal to the frictional force. Got it? So what is the frictional force? So the question says, what is the pushing force? You see, he applies, he pushes the force of the box at 80 Newton, right?
Friction is 80.
Correct, you're right. Okay, so friction is also 80. Okay, because the forward force is equal to the frictional force. Right, so hence, thus the frictional force is 80 Newton. Okay, so this is based on the balance opposite forces that are acting on the okay. So these are all the explanation, especially when you need to bring in this F equals to ma concept. You have to explain it clearly, right? Okay, so you can jot it down. Now, Jane, once you jot it down, just let me know.
Okay. Can already.
Okay, good. So I think there's no more other questions from this paper. The rest. Oh wait, there's still a few more at the back. Okay, let me clear these writings first. Now, so what is the direction of the frictional force? It's definitely in the opposite direction, right? Opposite direction of the horizontal force of 80 Newton. Okay, let's write it down. Okay. frictional force is always acting in the opposite direction. Well, it's in the opposite direction as that of the horizontal pushing force. Okay. All right, so we got this down. Okay, once you're done, just let me know. Okay, Jane, you're done with the statement. Hi, Jane, you're there?
Yeah.
Okay, can. All right, so let's move on to part C, yeah? Part C. Sorry, Jane, did you say
Wait.
something? Mhm.
Wait.
Okay, sure.
Okay.
Okay, can. All right, so for part C, now the box is then moved onto the polished section of the floor. So he continues to apply the same force, and the box accelerates at 1.5 meter per second squared. So you can calculate for the box the force causing the acceleration. So what is that force? You're supposed to find force. Which formula do you use?
Wait.
So you have the values of acceleration,
Okay.
you also know the
Wait.
mass. The mass is given as 20 kg. Yeah, 20 kg.
1 point. Wait.
Yes.
20 divided by 1.5.
So which formula do you use? F equals to
20 times 1 point.
yes, times, right? So F equals to MA, yeah. So it's 20 times 1.5.
20 times 1.5.
Yep. 20 times 1.5. So what is 20 times 1.5? You get 30 Newton, right? Okay, 30 Newton. So since you know that this is the net force, the resultant force is 30 Newton, are you able to find the frictional force? Any idea? So just now the pushing force, the same force is applied on the box itself. The pushing force was how much? It's actually 80 Newton, right? But now the resultant force is actually 30 Newton. Right, 30 Newton. So how do we find this frictional force? You know what I'm trying to say? Keep in mind that the resultant force is the F equals to MA. Right, resultant force is equals to 30 Newton. Right, and then your forward force, your forward pushing force, the forward pushing force is actually equals to 50 Newton, right? Or was it 80? Sorry, 80 Newton. Sorry, a little noisy. You can still hear me, right?
Yeah.
Okay, good. So this is 80 Newton. That's the forward force. So how do you think you can find the frictional force? Any idea? Jane, any idea?
50.
50, correct. Okay, because the resultant force is 30, forward force is 80. So it will give your resultant force. The resultant force is equals to the forward force minus the frictional force. So since this is 30, right, this is 30 Newton, then the forward force is 80 Newton. So the friction, right, minus the friction. So you just have to take the 80 minus 50, so frictional force will therefore be 80 minus 30 is equal to 15 Newton. Okay, got it?
Yeah.
Very good. Okay, so you can jot this down. Okay, so just jot it down. When you're done, let me know.
Okay. Okay.
Okay, so that's good. And we are done with this paper. This is the worksheet 4.1. Any questions so far? All right, just applying the F equals to MA throughout the whole practice questions. Okay, so we still have a bit of time. We need to go to the washroom. If not, I'll go on with the next set of papers.
No.
Alright.
Can
Okay, can, no problem. All right, so let's take a look at the next set of worksheets. Okay, where is this physics? All right, hold on. Let me open up the file first. Okay, so you do have this, you do have the worksheet 4.2, okay, the worksheet 4.2, dynamics. Alright,
4.2 I
like
have.
to, sorry, you have
4.2 I
4.2.
have.
Yes, yes, okay, good. Alright, so I would like you to try the question 1 and question 3. Just the MCQ question 1 and 3 first. Okay. Jim, I'm at the background, so when you're done, just let me know, right? So just try the MCQ question 1 and 3. 1 and 3.
Okay. Which question again? Sorry. 1 to
Oh no, it's just 1 and 3.
1 and 3.
Yes, you don't have to do 2. Question 1 and 3, right?
Okay, okay. Okay, can already.
Okay, so what is the answer for question 1?
Question 1, I put C.
What is the resultant force?
20.
20, right? Okay, so resultant force is 20. So F equals to MA. So wouldn't it be 20 divided by 20 to find A? Right, Jane?
Yeah.
Yeah, so it should be B, ma. Because 20 divided by 20 is 1. Does it make sense? How did you get it?
B.
B is the answer. Because using F equals to MA, you have your resultant force is 30 minus 10, which is 20, and then mass is 20 kg times A. So to find A will be equivalent to 1 meter per second squared. Got it? So it's 1 meter per second squared. Right? Any questions for this? No, so B is the answer. Okay.
No.
Yeah, okay, can. Now this is the working. If you want, you can jot it down. Next, scroll down now. Or you're still writing?
Well.
Okay, can.
Okay, can already.
Okay, so let's move on to the question 3. Now, what is the answer for 3? The greatest acceleration. So the mass is actually constant for all the 4 options, right? But it's the resultant force
Can already.
Can already, yeah, okay, can. Right, so I was saying that for question 3, what is the answer? How do you find acceleration? To find acceleration, you're going to take your F divided by M, right? Yeah, take the resultant force divided by M. So if let's say the acceleration is the greatest, then the resultant force must be the greatest because acceleration and resultant force, they are related, they are correlated, they are directly proportional. So what you have to do is to find the resultant force in each of the options here. So you can see that for option A, F, how do you find F? F will be 80 plus 20, which gets you to 100 Newton. Because both forces are moving in the same direction. Then what about this resultant force? F equals to 80 minus 20, which gets you to 60 Newton. Alright? Okay, then option C, since they are the same forces, you just have to add them up together. The resultant force will be 80 plus 40, which gets you to 120 Newton. Right, and then this is in the opposite direction. So the resultant force will therefore be 80 minus 40. That gets you to 40 Newton. So you have to work out all the resultant force for the 4 options. So you can compare which one has the greatest acceleration. So which acceleration is the greatest?
C.
Yeah, C. Okay, so this is because the resultant force is the greatest, 120 Newton. So it makes the acceleration to be the greatest as well. Alright, if you want, you can jot it down. Okay, now after you've done with question 3, move on to the question 4. We move on to the question 4. Okay, jot it down.
Yeah.
Alright, yeah, okay, good. So let me clear the
Yeah.
writings.
Yeah.
Okay, so all right, can you take a look at question 4A? Just work on 4A first. Now, how is it, Jane? Could you do the question? What is the resultant force?
Newton.
Sorry?
7 Newton.
7 Newton. So that's by taking 12 minus 5, which is 7 Newton. Okay, so can you work out the acceleration first? So how is it the acceleration? Did you find the acceleration?
1.4 times 7. Is it no? Wait,
No.
1.4 divided by 7.
So you can use your F equals MA formula.
Yeah, 1.4 divided by 7.
But 1.4 is not the force. 1.4 is actually the mass.
No, sorry, 7 divided by 1.4.
Yeah, that's right. 7 divided by 1.4. Got it? So 7 divided by 1.4, how much would that be? Did you have 5 meters per second squared?
Yeah.
Yeah, lor. So that's the answer for this. Okay, so 5 meters per second squared. Can? Okay, let me jot it down. Yep. Okay, you can jot down the working.
Okay.
Okay, done, Jane?
Yeah.
Can, okay, good. So hopefully for tomorrow's test, you can just do a revision tonight. These are the typical questions that you will see for your this Newton's second law. All right, can? Okay, so just revise whatever I've explained to you. You should be able to get it through. All right. So if there's any question, you can still text me. Is it okay, Jane?
Yeah.
Yeah. Okay. So let's stop here today. I'll see you back for the class next Tuesday. Yeah.
Okay.
Right. Okay. Take care then. Bye bye.
Yeah.
Bye bye.
Bye bye.